Hello, welcome to PreCalc. This is our first official notes video. We are going to be on 1.01. Now, I'm going to upload a document on Google Classroom that will be the parent function. So I would like you to go over that. You should go over that before we do these notes. So if you haven't taken a look at that, pause the video now, go back to Google Classroom and look up that sheet with all of the parent functions on it and their graphs. And you are responsible for memorizing all of those graphs. So you should know that if you are given y equals x squared, you should be able to quickly graph it. You should know in your head that it looks like the U shape. Absolute value, your V shape, you should be able to quickly give me like 3 points on it and be able to do a nice sketch of that graph. Very important. You've been working on those since algebra, and now they should be coming to you a little bit faster, a little bit easier. So 1.01 pre-calc. So that's really the beginning part of our lesson. It's just looking over those graphs and what they're supposed to look like. Then we're going to be talking about transformations of those parent functions. And then we're also going to talk about some combinations. All right. So the first one, I want you to write the shifts in words. So first, I'm actually going to go through and write out all the problems first because I'm going to want you guys to do some of them on your own. So the first one is f of x plus c. B will be f of x minus c. C is f of x minus c. D, f of the quantity x plus c. E is negative f of x. And f is f of negative x. So what I'm looking for here is for you to look at this and say, okay, f of x, if the plus c is outside of the parentheses, that tells me that I'm going to move f of x up c units. So if it was plus 5, I would move it up 5 units. Here, since minus c is outside, you would move it, you guessed it, down c. So take a moment, pause here, and finish filling these out. It's either left, right, up, down, or reflected over the y-axis or reflected over the x-axis. Okay, pause and then come back and we'll go over the answers. All right, so this one, when it's inside the parentheses, you should recall that that is opposite of what you think. So this one is going to move right c. This one is plus c. So again, inside the parentheses, opposite of what you'd think. So we'd move left c. Here, the negative is outside the f of x. So if it's out in the front, our y is being negated, which means we're reflecting over the x-axis. If the x is being negated, I should say negative x. If the x is being negated here, that means you're reflecting over the y-axis. Okay, so those are your general shifts and reflections. So now we're going to take a look at a couple of different graphs and talk about what is their parent function and then what is the shift that's occurring. So I want you to do all of these without, that's how we write without a calculator. I want you to give me a nice sketch of these functions. So have that other sheet open as well. If you printed it out, you can have it right next to you. And you first want to identify what is, that's just an X in there, what is the parent function. So to find your parent function, you're looking for, so that's negative x squared, that says. You're looking for getting rid of any negatives, any numbers that are being added or subtracted to your base. So the parent function is the basic bare bones as you can get. They're the ones that are on that document that I uploaded. So very basic graphs, and then we're going to shift them. So first, I'm drawing in my axes here, x and y. I want you to identify your parent function. So I'm calling that PF. So here I would take off the negative in front of the x, so my parent function would just be y equals x squared. So if I graphed that, I would graph the point 0, 0, 1, 1, negative 1, 1, and I would have parabola that looks like this. Now, since the x is being negated right here, if the x is negated, that means we're reflecting over the y-axis. So if I take each of these points and I reflect it over the y-axis, nothing actually changes. So this one is the exact same graph as its parent function. So f of x is equal to negative x squared, which should be, oh, here that 2 should be outside the parentheses. Let's see. There you go. All right, so that's reflecting over the y-axis. And so in that particular case, nothing changed. Now for b, we're going to do f of x equals the square root of x minus 2. So I'm just going to freehand these axes because I can't use a ruler here. Identify my parent function. So to do that, I'm taking off any negatives, any numbers that are being added or subtracted. So here I'm going to take off this minus 2. So my parent function is just the square root of x. It's a very basic, so my equal signs are looking like z's. So now I want to look at this one right here and say, well, how is that different from my parent function? Well, there's this minus 2 over here that we had taken off. So the minus 2 tells me to go where? Left, right, up, or down. If it is under the radical, that's going to tell you it's going to go left or right, and it's going to be opposite of what you'd think. Versus if it had been like this and it's outside the radical, then you would shift it down 2. But here, we're going to go opposite of what we think, so we're going to go right 2. So first, I'm going to graph the parent function, do a little sketch. So if I put in a 0 in for x, that's the point 0, 0. The square root of 1 is 1. So if I put in a 1 for x, the y would be 1. I don't want to do anything that's not a perfect square because I want to make it easy on myself. So I'm going to put in a 4 for x, and the square root of 4 is 2. So when you do your parent functions, you should always be able to give 3 nice points. So this is just the square root of x. Usually I was doing those dotted. Let me do that again. Kind of dotted. And then we want to shift all of those points. So we have 3 nice points. We want to move them right 2. So I'm going to take each one and then just move it right 2 and then connect. And this black graph, that's going to be f of x equal to the square root of x minus 2. Now, you do not have to graph the parent function on here if you can do it without that. But remember, you can't use a calculator, so you need to be able to think, what is my parent function and where is it being shifted? Could you do a table? Of course, you can do a table too, but I want you to get in that mindset because it helps us to do them a little bit faster sometimes to know that parent function and then see where it's being shifted. All right, to C. For this one, we're doing f of x equals negative x squared. So no parentheses this time is the big difference from letter A. So first we want to talk about what is our parent function. So the parent function, we're going to take off that negative out in front. It would just be y equals x squared. And then since there's a negative out in the front, we're asking ourselves, is the x negative or is the y negative? And in this case, since it's not like it was before, where the negative is next to the x with the x in parentheses, that means that the y is really being negated, and we just divide it over that negative. So if the negative is out in front without parentheses, that means y is negated, which means you're reflecting in the x-axis. If the x is negated, then you're reflecting over the y-axis. Let's do our parent function. So 0, 0, if I put in a 1 in for x, 1 squared is 1. Negative 1 squared is 1. So this is my parent function. Doesn't look great. Still getting used to these pens. And then we're gonna reflect it over the x-axis. So this point stays the same. This point go down one again. And this is something that should look really familiar. You guys have graphed y equals negative x squared a lot. So y equals negative x squared, or f of x equals negative x squared, is just an upside down U-shaped curve. So when it's negated, it's reflected over the x-axis. And the last one we're going to do here is f of x equals absolute value of x minus 2 minus 1. So go ahead and write down, pause the video, write out what is your parent function, write out what are your shifts, graph your parent function, and graph it with the shifts. Okay, so you guys should have figured out that the parent function was the absolute value of x. It's shifting right 2 and up 1, down 1. That one is what you'd think. And if we graphed this, we would graph absolute value of x. So give 3 nice points. I'm going to do a nice dotted. This should be a V-looking graph. And then we're going to take each of those 3 points and move them right 2 and down 1. So I'm going to go, oh, this one's off a little bit. Let me just move that line up. So we take this, we go right 2 and down 1. Here we're going to go right 2 and down 1. This one's going to go right 2 and down 1. Use a straight edge. Nice V-shaped curve. Absolute value of x minus 2 minus 1. Okay, so again, you should be able to do those without a calculator. And when you can find the parent function, I want you to find the parent function and then do those shifts, as opposed to creating a table for all of them. All right, next we're going to be talking about combinations. So you should have done combinations in geometry when you guys did transformations. It's when you see a combination, it's an little open circle is the notation. Okay, so we're going to get to that in a minute. But before we talk about the open circle combinations, we're going to talk about your basic operations with more than one function. So you're going to let f and g be functions with overlapping domains. Overlapping. So if you wanted to find the sum of those functions, so f plus g of x, what you would do is you would find f of x, you'd find g of x, and you'd add them together. So f of x plus g of x. Now let's talk about the difference. So if I was finding f minus g of x, I would take f of x minus g of x. If I wanted to find the product of those two functions, so this we're writing, there's no symbol in between f and g, they're right up next to each other. We would take f of x and multiply it by g of x. So you'd evaluate whatever if you had a number in for x, you could put that in, or if it's just an x, you would evaluate it just with an x. And then lastly, our quotient, which is our division, f divided by g of x. Same thing, you're just going to take f of x divided by g of x. So I'm not going to go through an example of all of these individually. I'm actually just going to do one with difference. So the idea here is you can just separate it and evaluate each one individually. The reason I'm doing difference is because there is a very common mistake, so I want to go over that. So f of x equals 2x plus 1, and then g of x is equal to x squared plus 2x minus 1. I want you to find the difference. So I want you to find f minus g of x. And then I want you to evaluate it at x equals 2. So that I could have also written it like this, f minus g of 2, without that little loop-de-doo. I'll just rewrite it for you. F minus g of 2. Same thing. Okay, let's do it. So I'm going to go on to my next page a little bit. So if it's f minus g of x, I'm really just doing f of x minus g of x. I do it in the order that they came. So f minus g, so we keep the f of x first. So f of x I'm going to replace with 2x plus 1, since that's what f of x is equal to. And I'm going to take x squared plus 2x minus 1 and put it in for my g of x. Then I'm going to subtract them. But since I'm subtracting this entire quantity, it's incredibly important that you remember parentheses. Please write yourself a note. Don't forget parentheses around that second set, because you're subtracting that whole thing. So now we have to just remember to distribute that negative 1 to everything inside of there. So we get 2x plus 1 minus x squared minus 2x. Negative 1 times negative 1 is positive 1. Now we're going to combine our like terms. The 2x's will cancel out. 1 plus 1 is 2. So we get negative x squared plus 2. So f minus g of x equals that. So now if I want to find f minus g of 2, all I have to do is substitute a 2 everywhere I see an x. So negative 2 squared plus 2. Notice there's no parentheses around that, so that's really like saying negative 1 times 2 squared plus 2. So the negative is not being squared because it's not in parentheses. So we have negative 2 squared is 4 plus 2, and negative 4 plus 2 is negative 2. So f minus g of 2 in this case would be negative 2. All right, so now we're going to talk more about the composites as opposed to our combinations before. So what we just did were combinations of functions. Now we're going to talk about composites, which is that little open circle. So the notation for this is f open circle g of x, and that'll be equal to f of g of x. So whenever you see this little circle, it's really important that you go from right to left. So you do the g of x first, then you're going to do the f function after that. I like to say when Gianni was just first starting to eat, we would feed him blueberries, and we had to cut the blueberries. So think of your open circle here as your blueberry, and you're going to slice that blueberry. And that's how it creates the f of g of x. And then usually students, once they see this, it seems a little bit more familiar to them from there. And the way you would read this is f of g of x. That's how you would read it. All right, let's look at a couple examples. So what we're going to do is I'm going to give you f of x and g of x, and then we're going to do a couple different ones for each. So f of x is 1 over x, and g of x is 2x plus 1. So I want you to find each of the following. So for letter A, we're going to find f of g of negative 1. So to do that, we're going to slice that blueberry, so it becomes f of g of negative 1. So to do this, you want to find your g of negative 1 first. So I'm going to find g of -1. Always work from the inside out. So I find my g function is up here. Everywhere I see an x, I'm going to replace it with -1. So that's -2 plus 1, which gives me -1. So g of -1 is -1. So now I'm going to find f of that answer. So f of -1. So I take my f function, which is right here, whichever one was labeled f of x, and I'm going to sub in a -1 everywhere I see an x. And 1 divided by -1 is -1, so that is my final answer. So f of g of -1 is -1. Let's try another one. So let's find f of g of -1/2. At this point, after seeing that, you might starting to feel like you could try it on your own. Pause the video, try it on your own. Okay, so first you should have found g of -1/2. You always want to work inside out. And find g of x, which is 2x plus 1. So I'm going to take out the x and replace it with -1/2, because that's right here, plus 1. And then you should be able to do all this without a calculator. So put 2 over 1, cross reduce here. -1 times 1 is -1, plus 1 is 0. So now I'm going to find, so this right here is 0. So now I'm finding f of 0. So f of x is 1 over x. So everywhere I see an x, I'm going to put a 0. Oh no, it's a 0 in the denominator. What does that mean? You are right. I'm sure you said that it is undefined. So our final answer for letter B is undefined. Next up, letter C. We're going to find g of f of 6. Okay, pause the video. Try it on your own. Okay, so again, you want to slice that blueberry. So first you're going to be finding f of 6. So we put in the 6 in for x, and then you're going to find g, since that's on the outside, of 1/6, because this whole thing is 1/6. So now I have 2 times 1/6 plus 1. No calculator, cross reduce. 2 goes into 6 3 times. I have 1/3 plus 1. I need to add those without a calculator, so I need a common denominator. So if this is a 1, I can multiply this by 3 over 3. So now I have 1 plus 3 would give me 4 over 3 for our final answer. And the last one, letter D, is f of g of 6. So I just switched the order there. Pause it, try it on your own, and I'll give you the answer to check. For this one, you should have gotten 1 over 13. Now, you also want to take note here that they're not the same. So this is not commutative. I can't do f of g of x and get the same thing as g of f of x. Just by switching the order in C and D, I did not get the same answer. All right, the last thing we're going to look at is if I don't give you a number, but I just give you in terms of a variable. So f of x equals 2x plus 5. And then I'm going to give you g of x equals 4x squared plus 1. And part A, I want you to find f of g of x. Okay, so we're going to slice that blueberry. Like a different color here. And so we're going to find g of x first. Well, we already know g of x. Right here is g of x. It's 4x squared plus 1. So this is 4x squared plus 1. So we want to now find f of 4x squared plus 1. So everywhere I see an x in f of x, I'm going to replace it with 4x squared plus 1. And then don't forget our plus 5 at the end over here too. All right, now I'm just going to distribute. So I get 8x squared plus 2 plus 5. Combine our like terms here at the end, and we get 8x squared plus 7 for our final answer. Okay, so we know that they're not commutative. So if I ask you next to find g of f of x, I could get the same answer, but not necessarily. So g of f of x, we're going to go the other direction. So first we're going to slice open that blueberry. So now we know f of x is going to come first. We already know, and since you can't see it on my screen, I'm just going to rewrite it. F of x is 2x plus 5. So I know this right here is 2x plus 5, which means I need to find g of 2x plus 5. That was an x. So g of 2x plus 5. So everywhere I see an x in the g function, I'm going to replace it with 2x plus 5. And don't forget, you still have to square it because the x is being squared. The only thing that goes away is the x. All right, now we just want to simplify. So I have a binomial being squared. Order of operations, I want to look at those exponents first. So whenever I have a binomial being squared, I need to write it out twice, double bubble, you might say, and then we need to FOIL it. So I would say pause here and try to finish this on your own, combining all your like terms, and then check back with me. All right, so make sure you FOIL this whole thing out here and just leave the 4 on the outside for now. So you guys have already done this now, so you would get 4x squared plus 20x plus 25 plus 1, and then distribute your 4 into your parentheses. We get 16x squared plus 80x plus 100, and then don't forget to bring down your plus 1. And then we have some like terms here at the end, so we can combine those to get 16x squared plus 80x plus 101, and that would be your final answer. So clearly these again are not commutative because we did not get the same thing as we got in part A. Okay. So that wraps it up for some of our parent function stuff and our composites and combinations. And I hope you guys are all doing well. I hope to see you soon. Pie out.